Okay, so welcome again. Today it's automated spatial analysis to predict electrical outages. I am really happy to have a colleague from Oracle here from Malaga, Rasmus Edwards, Cloud Solution Engineer. So I'm just the moderator. Rasmus has done all the work for this webinar today, and I'm excited to hear what he has to say. It's a few slides and a lot of demo. So Rasmus, so you want to give a little summary of yourself, and you can begin.
Right, thank you, Carol. So I can see some more people have dropped in now, so I would like to welcome you. As Carol said, my name is Rasmus Edwards, and I work as a cloud solution engineer here in Oracle. And I worked here for a year now, and I'm based in Malaga, Spain. However, I'm working remotely towards the Scandinavian market, and more specifically Sweden, where I'm from. So that's a little bit about me. I work with cloud solutions and infrastructure and data management, but I have a background within GIS, both academically but also working. So that's something that lay close to my heart, and I tend to interact with spatial customers in Sweden. So without further ado, I will start the presentation. So that was the brief introduction of me. So I will soon dig into the demo itself and a little bit the background of automation of spatial analysis, but I'm going to do a quick recap of spatial data for those of you who are not that familiar, and also the concept that we are working and the agenda we're pushing from Oracle. So usually I tend to have some kind of statistics like I have in the bottom left corner here, why spatial data is relevant. And I think a lot of people, most people have now realized that. So for example, Forbes wrote in 2019 that more than 65% of businesses consider location intelligence critical to revenue growth. But today I was thinking I'm gonna tell a short story, a story that took place in 1854, which is this is a classic story within spatial. Some of you might have heard it, some of you might not. And it's about Jon Snow. And no, it's not the Jon Snow that many of you are familiar with from Game of Thrones. This was a Jon Snow living in London in 1854. And London at this time was not really a pleasant city to live in, really. People were crammed in very tightly. They were living in very poor conditions. And on top of that, there was a big cholera outbreak in the city itself, and people were dying in piles. So many thought this was mostly due to airborne, and so people tend to not want to help people and treat them. But Jon Snow, he actually took to spatial to try to analyze this, and he went not only to look at the map as a visual tool, but he started looking at where was the people located that was dying and got cholera. And he also pulled up data on where are those water pumps that they got supplied by, and he could instantly see there was a correlation that the people that died and got cholera, they used a specific water pump, and they could shut down the water pump, and less people were dying, less people got cholera. So they could also, so it not only saved some life, he could relate it to that the water was the biggest cause to this disease. And this was back in 1854, but I think it really tells a good story how they used a spatial analysis. He didn't just visualize the data, he used the data location-based and draw a conclusion from that. And that's everything what you should do with spatial data. And I think we have much to learn, even from things back in 1854. So that's a little bit of a background story. If you look today, in today's landscape, we can see that a big struggle today is that there is a kind of a wall, as you can see in this picture, where you have your GIS department in one side and your enterprise in the other side working. And sometimes this can be isolated, and when someone needs to do something from the enterprise that has to do with spatial data, they need to do a request to the GIS department, and it leads to data isolation. And in some cases, actually the people doing some enterprise work, some analysis work, they can actually use this GIS data. And this is a barrier that we want to break down, because we think in some cases it could be really useful for anyone to do some spatial work and have access to spatial data. Usually there is even a separate GIS database, and then you have an IT database. So you can't reach the data, the GIS data, if you're not connecting to the new GIS database, and then you have an IT database for the other purposes. But procurement maybe want to do something that is some kind of analysis that needs location-based data. So what we would like to see is a unified database, which is reinforced with strong security to let everybody get access to different kind of data, in this case spatial data. So as you can see here, we support a lot of different workloads. I think many of you maybe have seen this picture, the converged database, as we call it. That's our strategy. You should do machine learning directly on the database. You can go ahead and store graph structures of data. And of course, today's session have spatial data stored and do spatial analysis. So why am I telling this? I thought I was here for some Spatial Studio and some how you would automate spatial workload. Well, I think Spatial Studio really enabled the whole enterprise to be able to do this spatial analysis that we have had for so many years and are very proven and useful and effective. Now with this tool, which is basically a user interface, for those of you who are not familiar with it, you can go ahead and start doing analysis visualization, and you don't need that much code background or SQL background. You can do your spatial analysis as a business user. So as you can see here, no code environment, simplified. You can expose your data through REST and so on. And I mentioned SQL, and that used to be the traditional way how we did this spatial analysis and did these queries. You ran queries towards the spatial database. But now we have this Spatial Studio, which operates on top of the database as a user interface layer, which enable very easy use of these tools that we had that is very proven and effective. So if we take a spatial data flow, how it could look like. So with Spatial Studio in this case, you could have a business user that do some sort of spatial analysis with the Spatial Studio. What happens in the background is that it creates an analytic view in the database, which targets some tables that you have done operate the spatial data. So it's a view. Every time you do a spatial analysis, it's saved as a view in the database. And then you can go ahead, actually, once you created that view, and you can extend it, right? Maybe you just do a simple visualization. Maybe you call that view to visualize something in a web application. For example, we have Apex in our database, which you can do web application. Or you can use this view to do further analytics, right? You maybe want to see what this spatial analysis, maybe you can get even more insight into your business. For example, with Analytics Cloud, which we have, or even machine learning. And this could be a typical workflow of a business user. And really, today my focus is automation. And automation doesn't have to be that hard to achieve with this. I think it's almost already there. So really what we want to do to achieve automation in this flow is to integrate new data which this view is applied for. So you have created this analysis with view, you have your requirements. Then you can take some fresh data, and the view automatically generate new analysis on top of that new data coming in. And that's really how you can enable automation. Of course, on top of that, you can then have a web application displaying this, or do notifications, as I will show you in this demo, for Slack or email to notify your users when these spatial analysis is done. So it's very powerful, and this is why I think Spatial Studio can enable automation for the regular business user. So now it's time for me to show the demo. So in my case, my spatial analysis is to try to predict outages in a power line network. So the scenario is there is a storm coming in, maybe in the coming week or in the coming days, where you have reliable weather data forecasts, and we want to predict which of these power lines would be at risk. And ultimately, you can extend that and look further into how many people would be at risk for outages and what segments are at risk, what are the data for those power line segments, and so on. And weather data is really useful use case for automation, since you have new data coming in all the time. So you could replace that new data with new weather data, and then you have your spatial requirements, and which I will show in this demo. So this is obviously, as you can see, Sweden, and it's Swedish data, since I'm from Sweden working towards the Swedish market, and it's open data. So you can use it for commercial use, and it's from Lantmäteriet, which is the mapping agency in Sweden, and SMHI, which is the official weather institute in Sweden. So let's dig into the demo. Carol, can you confirm that you can see my screen?
Yes, I can.
Perfect. So firstly, I will log in to my Spatial Studio, which I have set up. So you just log in with your credential. This is deployed in the marketplace in our cloud, so running on a compute instance. And you're faced here with a screen. So in this case, it's empty, but here you could save projects and so on. I think some of you have seen some previous presentations on Spatial Studio. You have a create where you can import data sets, start projects, or enable connections to your database. In my case, I already actually imported the free data sets that I will be working with today. And I did that by importing them as shapefiles. And once you import them as shapefiles, they directly store in the database, which is really useful because then you have them there and you can just connect to your go for your database and retrieve these data sets. So let's take a look at how they look like in Spatial Studio. So I will go ahead actually and add all of them. I simply drag and drop, and I found the bounding box and where the data is located. So we have the power lines, and we have the Swedish borders. You can also drag it up. And we have the forecast data. So the forecast data looks a bit clustered, but actually each of these dots represent forecasted weather values in Sweden. So actually, if I, for example, go in here and I go to settings and I color it based on data, and then gusts, which is temporary high wind speeds, is starting to be a little bit more clear what it actually visualizing here, right? So you can already see there is some strong winds here in the Baltic Sea, along the Norwegian border. So it's becoming a little bit more clear where power lines might be at risk. We can also drag them up so it makes more sense. But as of now, we have a lot of data that is actually not really relevant, which is not near our network. So my first operation will be to have the weather data that is within the Swedish borders. So I will go ahead and I will press spatial analysis on my forecast with weather data. And I will use, or actually, let's take a quick look here. So here is all the spatial analysis that you can do with SQL, which you now get a visual representation. So we actually have a bunch of good tools here to filter, combine geometries, transform geometries, and measure geometries. But in this case, I will filter and I will use return shapes that are inside another. So first of all, we need to name the layer. So this will be data within Sweden, so weather in Sweden. So I will just call it weather Sweden. And, or we could actually in this say gusts, because it's gusts we want to look at. And layer to be filtered is our forecasts. And we want to use Sweden to segment and find data. So then I simply click run. And there we go. And it appears analysis here. And it's a view now created in the database. So I can drag and drop. Let's turn off the other layers. And there we go. We now have all the relevant weather data. But we want to identify the gusts that is strong, that could cause damage to infrastructure. So for that, we will go back and use spatial analysis. And we will actually use return elements filtered by non-spatial rules. So this is just filtered on the data qualification. So here I will go ahead and call it gusts above 23 meters per second, which I will come to in a second. I will choose gust here, the temporary wind speeds that we want to look at. And I want to select all the gusts that are predicted above 23 meters per second. Why 23? Well, that's a number I choose. I went to the official weather site in Sweden. Above 25 meters per second is considered storm and could cause damage to infrastructure. So 23 is kind of a safe zone. So I use 23, which is near the storm consideration. And I will go ahead and click run. And it goes quite quick, and we already have the new layer. And now we have actually the individual forecasted points where the forecast is, where the weather is, the gusts are predicted to be strong. This is data I have tempered with to do a storm scenario. But we can see around the island of Gotland, Norwegian border. So now actually we just have one final operation, and that's right to find out which part of the power lines that are at risk. We can kind of see it, but we need to do this final spatial analysis. So I will now use the power lines, do spatial analysis, and use return shapes within a specified distance of another. And I will call this one for power lines at risk, for example. Power lines want to be filtered, and we want in this case to use the gusts above 23 meters per second as the filter. I will write 10 kilometers. I'm from Sweden, so we're gonna use the metric system today, since I'm familiar with that. And essentially now we're selecting all power lines that are within 10 kilometers of this predicted forecasted gusts. And let's see if we have any result. Yes. So now we have actually, with the help of spatial analysis, selected these power lines that are at risk. So now we know which power lines are at risk, and we can take further actions or do further analysis on this. So you could now export this data, and in my case I have exported it and imported into our client or our product Oracle Analytics Cloud to do further analysis. So this is just an example how you could extend analysis. So what I have done here, I will go ahead and refresh this view. I think I've been logged out here. So Oracle Analytics Cloud is another product we have in our cloud to do visualization, analytics, some built-in machine learning capabilities. So I have done a pretty simple dashboard here, and I've looked at, I had data on how many customers that was connected to these power lines, which is just an example. And I can then now visualize it, but also, as you can see here, use as a filter, use these power lines at risk, which I have imported as a filter, and I can filter out how many customers are supplied by these power lines that are at risk, and you can kind of assess the magnitude of this storm coming in. So this is just an example of how you can take further actions. Of course, you can have a kind of a website which would notify your workers and so on. But this is one way. But this is good and all, but we were talking about automation, right? And indeed we are. And so how would it look like if you do automation? Well, you would use something like Integration Cloud or any integration product to pull in new weather data, which this new view, power lines at risk, would then operate and filter on top of to find. And most of the time, right, you would not see anything. There would be no storm, no risk coming in. But once it do, you would like to be alerted and take further action. So you would have some automated integration of this weather data daily or whenever, how often you want to pull in new weather data. I will show you how it would look like, but in my case, I will actually do the import manually since I have another data which is simulating a new storm. So I will actually use the classic old Oracle SQL developer. And we will go ahead and connect to my database here. And I will do a manual replacement of the data, which would be automated, right, through an integration product. Let's see if I connect here. There we go. So let's go ahead and look at the tables. So the data you would update regularly with some kind of automated integration would be the weather data, right? So what I will first do is I will delete the data in our weather data that we just displayed in the demo. That looks about right. Bear with me. It's a lot of rows, 35,000 rows deleted. I will also do a commit. And it's committed. And now I will do load in the new weather forecast here. So I will import data. And I will choose, so I have a new forecast here, which I have, which is also simulating a storm coming in or very strong gusts. And I will simply load this new data in. And then I will track it. So I have longitude and latitude, which is the position of the data, the value, which is, in this case, the value is gusts, wind speeds. And let's see. So we're now injecting the new data into the table itself. And there we go.
Hey, Rasmus, let me interrupt. There's a question.
Yeah, please.
For doing this analysis of gusts, we need weather data for the future. How can you get the future data into your database to analyze?
Great question. So in this case, the data is exposed by SMHI, the weather organization in Sweden, and they expose it through a REST API, which is open for the public. So really, you can use any kind of, like we have, for example, Integration Cloud. I have set up a flow there, but obviously there is no storms around at the moment in Sweden. But you could use a product like Oracle Integration Cloud to pull this REST API into your database. But basically, any integration product that can enable API to pull an API into a data source would do, right? So Oracle Integration Cloud is one example, but there is other products out there.
Thanks.
So yeah, we have now updated this weather data manually, which would be automated. And then you could actually have an auto refresh here, which would reload the data. So go ahead and reload it. A second. Seemed like we got an error. I will go ahead and actually update. My SSO got timed out. This is the thing when not working in the same product all the time, that your different authentication get timed out. So let's see again. So let's retry that one. Reload data. So now I'm updating the data connection to which this view is working on top of. And we have complete. And we can see how it got updated. So here, of course, you would have some sort of auto refresh plugin with auto refresh the connection to the view in the database. And then you now automatically have the analysis on the new weather data. So this was kind of extreme scenario, but you can see here we now have even more power lines at risk in this case. As I said, most of the times, of course, there would be no power lines at risk, but in those scenarios, when there is, you get it automatically refreshed. So this is a use case how you can use this automated spatial analysis. But I have actually added another feature on top of this, because since there is not a lot of storms around a lot, you want to notify once something is up and you need to do further investigation. And that's actually when I have done here is to do a notification for Slack through using this spatial analysis, this spatial analytic view. And I done that in Integration Cloud, which I was talking about. I've been timed out there as well. I seem to be good at getting timed out. Okay, now I'm in. So I will not go into too much into Integration Cloud. It's a low-code integration tool, which is really easy to use. But let's go into the integration flow that I set up for this automatic notifications, because that's very visual. I think all of you will kind of understand what I've done here in the integration flow. And it will also, of course, here you would also set up the weather data, and this would be triggered then every time you pull in the new weather data. So what you would do, you would pull in the new weather data and apply the automatic spatial analysis. What I'm doing here then is to schedule an integration, which would look here, I look at the view. So the power lines at risk. So it selects the view in now my database. I then do a if here. And if these power lines at risk contains more than 0 rows, then send a message to Slack, otherwise do nothing, right? Because if the spatial analysis have detected power lines at risk, then we want to inform our organization, our team, work team. And then I have added a Slack adapter, and this is very easy to set up. I have a video on this, and it took about 30 minutes to set up, and I will send message. So here I have the logic. What you would do is to, like I said, to schedule this. So you would automatically run this and check if you need to send notification to Slack. But in this case, since it's a demo, I will go ahead and do an ad hoc request on this. So if I go ahead and click run here, and I go for submit now. As you can see, you can do a schedule of this, which would be preferable in automation workload, but I'm going to do the ad hoc requests. And we wait for a couple of seconds, and hopefully I will get notified. So this would simulate maybe a workforce that, there we go. So now I got notified in a dedicated channel, which is weather warnings. As you can see, I've done some tests before, but this of course you could do much more neat with a kind of a more graphical box here, which Slack offers. But the benefit of this is that you have a dedicated channel and you get notified, and the people that it concerns get notified, and you could have this as an important channel. What you do here is up to your imagination and your business requirements. What I've done is linked to the view, the dashboard in Analytics Cloud, and from there the people who it concerns can take further action, right? Okay, these are the areas that are at risk from this storm. We maybe need to call in more workforce for this week, and in case something happens, whatever actions you need to take. So that's an example of how I built from a simple, like a spatial analysis, and then took it further out in other products and in the organization to use spatial analysis for other areas and analysis. So and this would then be implemented in an automated way. So let's head back to the slides itself. And I will go through a quick recap because it was a kind of an extensive demo, right? And we need to I like to at least come to a closer and see what did we really do. So I have this more overview architectural image. So I had an API from SMHI where I put my data. I would then schedule an integration of this weather data into my with the product, for example, Integration Cloud, and I would save that in my database. In my case today, I used an autonomous database, which is in our cloud, and I would then set up an analytic dashboard, which is based on the spatial analysis that we did in our Spatial Studio. You can then do reports or embed that into a web application. Really, your imagination is what can be used here. I then have a connection in Integration Cloud to Slack. So in case the view finds any power lines at risk, notify my workforce, and then they get connected to that view or wherever you want to take further actions. So that's a little bit of how the bigger picture was set up in this scenario. So that was everything I like to say. I can, just before we head into Q&A, so for those of you who are not familiar with Spatial Studio, it's a program that you can use now. It's been out for 1 year, and you can deploy it both on-prem and also an OCI in our cloud from the marketplace. You need a database license and you're good to go. It's supported for both Standard Edition and Enterprise Edition, since the license is now included, the Spatial and Graph license, since December. So thanks for tuning in, and I would like to open up for any further questions. I don't know, Carol, is there any more questions to come in? Or
I don't see any at the moment. That's okay. You did a great job. I think it's a lot of information for people to consider. So if you do have any questions in the future, feel free to reach out to Rasmus or me. I can get through to Rasmus as well if you have any specific questions, either about the use case or Spatial Studio or Spatial. We'll be happy to, we're getting a lot of kudos. Thanks for doing the demo, that you did a great job and a good explanation. So I have to agree with that. I think that's it for the moment.
Right.
So thank you, Rasmus. It was great.
Yeah.
You didn't, oh, look, it's phenomenal. Thank you so much. So great example. Thanks. lot of good information here. Just a lot of good kudos.
Yeah.
And yeah, thank you for this session. Again, we don't need to take the entire hour to show a really good example and a really great use case. All right, so I guess if that's it, besides the kudos here, I guess we're done. And thank you everybody for attending. Again, subscribe to the Ask Tom Spatial Maps sessions, upcoming sessions. So you can get the Python one coming up at the end of August and more coming in the future as well.
Yeah,
all right.
I guess I can add also, if you're interested in any process, how I set this up, you can find that some of the videos at the Spatial and Graph YouTube channel, and I have a couple of them on my own channel, which is Rasmus, my first name and last name, and 2. And there I also go through the integration bit. I go through how to make a web application out of these dashboards, and of course the spatial analysis and all of that in more depth. So if you're interested in that, you can check that out.
Great. And then Jean put a lot of good URLs here for the Spatial TechCast days that we just had. You can look at those studio customer sessions and demos as well from our own team. There's just a lot of information out there. It's just hard to tell everybody about them all now. But again, just try to subscribe and you can keep updated in what's going on. And in the near future, we will be having a new studio release coming up as well. So there'll be a lot new functionality for you to start using. So thanks, everyone. Thanks, Rasmus. You did a great job.
Thank you for having me.
Your time. Thanks. All right. See you later. Bye.
Bye.